So this is lesson 6, and we're going to really focus on the calculation of our beams and our joists. And the assignment that is due at the end of this lesson will be due at the end of the week. I want to give you a lot of opportunity to practice this and try this out. Everybody's project is different, so I'm not too concerned about who's copying who or who's working with who. That's really not a concern. It's just a matter of understanding the process. If you can get this done by the end of the day, great. If not, I will give you to the end of the week. The problem is that our next assignment is due on the class day the following week. So the sooner you submit this, the better. So what I've done is I've taken my project file and I've broken it down into certain dimensional values to reflect all the different information that we need in order to work with this project. So I'm going to just zoom in on a section here. This PDF that I have of the CAD drawing is available online, so you can print it off and mark it up any way you want. But what I did was I broke it down into specific dimensions that relate to the tables and the charts that are on the Ontario Building Code. So every zone I've identified the span of the joist, the overhang, and also the supported length. The supported length is halfway between the two supports on either side. And in the case of zone 1, we don't have another support on the other side. We simply have an overhang of 11.5 inches. So remember what we talked about. Our typical overhangs are 2 feet. This one's slightly shorter because it is a staircase. You usually want to leave it within about a foot of the staircase so that you can tie in the riser supports right into the side of the beam. So let's take a look at section A, and I've drawn this specifically to show you how we're looking at the side of this. The image that's on the left side is exactly what I would expect from you. So you can use this as a template and simply fill in the blanks. I'm going to first highlight all the building code information. So anything that you see in brackets here, these are the building code references, the numbers that actually come off the tables and the charts. So anytime you see a bracket like this, that's what it's referring. With some of the other stuff that we have here, so for instance, I've got spans. And what I'm trying to do is hopefully show you where I'm getting all this information from. In here, I'm going to go back to the highlighter. Oh, I lost that one. That's okay. Go back to the highlighter, and I'm going to show you where that highlighted information is coming from. So for instance, in zone number 1, there is the span. Oh, I can't do that with this program. Okay, I'll do it here. The span that I have here indicated 11 foot 4.5 inches is this span right here. So that's what I'm showing in the different projects here. So let's see if I thought I could highlight it. Nah, it's being a bit stubborn. That's okay. So when we're looking at our supported length is half that distance plus the overhang, or I've already calculated it 6 foot 7 3/4. If you want to do the math, which is basically the 11 foot 4.5 divided by 2, which is 5 foot 8 1/4 plus the 11.5 inch overhang, and that gives us our 6 foot 7 3/4, and that's where that number comes from. This 2 foot is an arbitrary number that we suggested on every overhang. It needs to be changed to 11.5 to reflect better what the information is. So that span, 11 foot 4.5 inches, is where this number comes from. And that allows us to look at the Ontario Building Code charts. We know that this is the number we're trying to achieve as a minimum. And these are the 3 values. You want to find at least 2 or 3. And these are the 3 values that I found, 12 foot 11, 11.8, 12 foot 2. So that's how we calculate the joist for each one of the different projects. And that comes right off the table. And if you want, I can just do this very, very briefly so you can see this. It's sort of a recap of what we've done numerous times here. So when I'm looking at the joist of 11 foot 4.5, I'm looking at this table here. I'm going to SPF 1 or 2, it's our only option. And I'm looking for a number greater than 11 foot 4.5. I don't want to use, and I made this note in a couple places, the 2x6s or 2x4s. So I'm starting at the 2x8 level. And the first one that I find here at 16-inch centers, remember where we go first, is the 16-inch center mark, is the one that will identify that distance. There it is, 12 foot 11 inches. It's a 2x10. 2 by 10 with strapping, 12 foot 11 inches. That's where I got this number. Okay, so that number in there, let's see if this will work with the highlighter. I'm sure it will. That number there is where I got this number here. Now again, because it is an OBC number and it's in brackets, I'm showing in brackets here. The 11 foot 8 comes from where? Well, if I go along here, there's my 16-inch centers. We're using the 16-inch centers first and foremost, and then only if necessary we'll go to 12-inch centers. And then here the last one is 12 foot 2. So those were my three choices that I've indicated here from this table. If I go to the other table that we have, which is the beam table, I'll show you where I got those numbers from. So our first, let me go back to the drawing. Just going to move this aside. Our drawing indicates that the actual beam spacing, the column to column spacing for beam number 1 is 6 foot 3 and an 8. That's what we indicate here. So when I show 6 foot 3 and an 8 down here, that becomes this number right here, column to column spacing. Our supported length is calculated right here, 6 foot 7 and 3/4. So we have our supported length, how much of that floor is being supported on this beam, and the column to column spacing. This one is a really close column to column spacing. So when we look at the table and the charts here, let me just slide that over, and I go into SPF 1 or 2. So let me just go to this table here and see if I can use the highlighter here. There we go. And I'm going to just change that color to that. We always stick with the number 1 or 2. That's given. We notice that our supported length is 6 foot 7 and 3/4. So where's the smallest value? There it is there, 7 foot 10. And that's why I've indicated here on the code it says 7 foot 10. Now I'm looking for the beams. So my first one with a column spacing of 6 foot 3/8 is the very first one that's on here. It's a very tight or close spacing, so I've indicated that one. And I want to do groups of 3. So I'm going to try to find a couple of 2 by 8s. So this one's slightly bigger, not that I need to know that. And then the next group of 2 by 10s, I've got the one at 12 foot 10s. I want to pick 2 or 3. Just to use different choices. I want to get an 8-inch there and a 10-inch, and sometimes neither one will fit and you have to go to a 12-inch, but I want to get one of each at least. So when I go to finalize my purchase or how I'm going to design it, I want to be sort of very common with the elements that I'm using, so I don't have to order different materials for each one. So that's where all that information comes off. I know this is a repeat, but I wanted to give you a template to follow through or follow along with the process. Okay, let's take a look at the next section. Now notice in here, and these sketch designs help because eventually we're going to draw a sketch through the deck or an elevation of the deck, and this tells you how exactly it's put together. Beam 1, there's beam 1, and then we have steps that come off the edge of that beam. And then we have our supported length or length of a joist, and then there's the house. So that's what we've done here in section AA. Section BB is much larger, so let's see how we've drawn that. Here's section BB. And section BB is basically this. There's the house on the left side, or the top of the frame. Here's the house on the left side. It gets supported on top of beam 2. It gets supported on top of beam 2. So the blue section of the deck is sitting on top of the beam. That's the blue section of the deck that's supporting on top of the beam. If we take a look at this, the magenta part of the deck is supported to the side of the beam and then on top of the beam in the lower section. Let's see if I can represent some of this here in color just to give us some variation. So this, that might be a bit of a dark color. No, that's fine. That is represented by the top portion of it. That's what that joist represents right along here. So we're looking at the side view of this, and then the next one is the magenta one, and that attaches to the side of that beam, and then it goes underneath here. So that portion of the joist is this portion of the joist, and then we got our 2 beams. Beam 2, there's beam 2, and beam 3, there's beam 3. So this is how the deck is supported. This is what it looks in plan. Remember, there's our step down. This doesn't have to be an accurate drawing. I don't know the size of that joist yet. I don't know the distances that are all involved in particular, and I'm not drawing this to scale. It's a schematic to help me do the calculations. That's what's important. So let's see where we're getting our numbers from. Okay, so the deck number here, 12 foot 8 1/4, that's the span on top of zone 2. So there's my 12 foot 8 1/4. I apologize. It's there too, but really I should be referring to this section in here. There's my span, 12 foot 8 1/4. That's where that number comes from. The next span is from joist or beam to beam. And that number is available on the right side of this table, or right side of this diagram, which is 9 foot 3 3/4 inches. And it indicates here joist span for zone 4. So let's draw that. And there it is right here. So the supported length on beam 2 is 12 foot 9 1/4 plus 9 foot 3 3/4, there's that number, divided by 2. Half the span of the joist on the right, half the span of the joist on the left. Don't worry about the overhangs. That's already kind of built into the calculation. We don't care about that. But it's those two numbers divided by 2 which will give us our supported length. That's our key number right there, 11 feet. Now, if you actually do the drawing, or do the dimensioning, sorry, on top of the drawing, it's half this width. That's where you pick up that dimension. And half this width is where you pick up that dimension. And there is my supported length for beam 2. So really closely associate between these two to try to understand where these numbers are coming from. This is not a very basic, simple explanation. It's something that you really need to follow the methodology behind. So I've calculated 2 joist spans. I've calculated 1 supported length for zone 2. Let's see zone 4. This is zone 4. This calculation is very different because this beam only carries half this joist and then this little section that overhangs there. Now, how wide is that section? Well, if I go to my drawing, I can see it is actually 2 feet, so that number is correct. This number in this example is correct. All right. So first of all, zone 2. This is zone 2 here, the blue drawing. And what I'll do here, again, I'm just trying to color code. When I studied engineering, I color coded everything. It just seemed to make more sense to me. Whereas the other zone, here we go, is zone 4. So zone 4 basically refers to this joist. Zone 2 refers to this joist. But beam 2 supports half a zone 2 and half a zone 4. That's what we got to calculate. So first of all, let's take a look at the joists. Okay, let me go back to this color. So the 12 foot 8 1/4, that's where this number is right here. That's where those two numbers are derived from. And then this is just looking at the tables once again. And I know I'm repeating myself. And for some of you that get this right away, don't worry about it. You see the tables and charts, figure it out yourself. You go along with it, no problem. For those that need the repetition, that's why I'm doing it. I mean, this whole concept that we're working on here is brand new to all of you. So, you know, the fact that we're working on this is something that, you know, that I'm repeating this is something to reinforce that learning. Okay, let's take a look at this one. Here's our joist span, 12 foot 8 1/4. So I'm back to this table. There's my floor joist span table. I'm looking at that now. Again, no 2x4s or 2x6s. I'm looking in these 3s, and the 16 inches are the first ones I look for. Okay, let me change color here because this is an OBC table. And I want 12 foot 8. Well, that's too small. I'd have to go with that one. All right. If I go to the next 16-inch chart, that's too small. I'd have to go to that one. And if I go to the next one, again, that's too small. So I may look at this and say, okay, I want to pick up one that maybe is at 12 inches on center. So I've got 2x10s. I don't have a 2x8. Let's take a look at a 2x8. That one's too small. This one works. This one works. So I've got a 2x8 and a 2x10. And you notice that even though the 16 inches work at the 2x10s, they don't work on the 2x8s. In fact, I made a slight error here. That one's too small, isn't it? Okay, let me delete that. It actually has to go to this one. There we go. So it's very easy to pick one and then be satisfied with it, but that doesn't give us the flexibility when we look at the overall design. So there's 12 foot 11. There's my 12 foot 11. Good. There's my 13 foot 8. Here's my 13 foot 8. Yep. And here's my 13 foot 1. There's my 13 foot 1. So what does the lettering mean? 2 by 10. So let's take a look at the first one. 2 by 10. Yep. Width strapping. There's my strapping only. Okay. At width strapping. 12 foot 11 is the maximum span at 16 inches on center. All the numbers are correct. Next one, I got 2 by 8 with bridging and strapping. 2 by 8 bridging and strapping. There's the strapping and bridging. Good. 12 inches on center. 12 inches on center. All right, I've got all the right information. The third one is a 2 by 10 with bridging. 2 by 10 with bridging. 13 foot 8. There's my bridging only. Great. 13 foot 8, 13 foot 8. It's all correct. It's very easy to make a mistake, and as you can see here, I've made some mistakes that I've had to correct and go back to. It's not something that we process on a regular basis, so it's easy to make a mistake. If you follow this template, it's a bit easier to match what we're doing and hopefully get the right numbers. Okay, let's take a look at our beam. So, review once again. Where does this beam information come from? Okay, what beam am I looking at? I'm looking at beam 2. This is beam 2. Now, beam 2 has several different scenarios. I'm taking the worst case. This is the worst case scenario, and that's why I'm using this number, 12 foot 11 and 1/8. That is the magic column to column number I'm going to use in my project. So when I come down here on this table, I'm going to switch to the actual number. So anything I'm highlighting in this yellow tone is the actual drawing number. My supported length, we calculated to be 11 feet. There's my drawing number. Anything that's in bracket is the building code number. So what do I need to know? I've got my supported length is 11 feet. My column to column is 12 foot 8. Okay, let's take a look at our table here. Oh, I've got it down here. So I'm going to delete all these. That was from the previous one. All right. I'm always using SPF 1 or 2. I don't ever use structural select. Supported length, 11 feet. Can't use 710. Can't use 910. There's the one I have to use. That's the row I need to use for my project. Okay? And that's what I've indicated here. That's why it says SPF lumber, 1 or 2, supported joist length, 11 foot 10. It contradicts this, but this number must always be larger than this one. Remember, the yellow color is the actual, the green color is the building code. Great. So what do I have that's available for my column to column at 12 foot 11 and 1/8? So I'm going along here until I find 12 foot 11 and 1/8, and there's my first one. Remember, we want to have at least 2, maybe 3. So there's my first one, and that's a 2 by 10, 5 ply. Okay, what's my next one? That's too small. There we go. That's a 2 by 12, 4 ply. So that's the way you indicate it. 5 ply 2 by 10 gives me a column to column of 13 foot 3. That's where that number comes from. 4 ply 2 by 12 gives me a column to column 14 foot 1. That's where that number comes from. And hopefully with this repetition, it starts making sense. So let's take a look at zone number 4. So zone number 4, if I take a look at my sketch diagram here, basically what we're doing is we're covering the beam number 3, the weight that's sitting on top of it. Remember, half of half of the joist length is already supported on beam number 2. So beam number 3 carries the other half of the joist plus the overhang, which is 2 feet. And so we have zone 4 here. Let me just use the right coloration. Zone 4 is the 9 foot 3 3/4 inch divided by 2. So there's my 9 foot 3 3 3/4 inch divided by 2. So that gives me the halfway point between that, plus the overhang of 2 feet. And that's how I get 6 foot 7 and 1/8 inch. So there is my numbering here. That's for the supported length. Here's your joist. There's your joist span. There we go. Looking at the tables and charts, there's 2 that are available to us. There's actually 3. There's a 2 by 6, but note this, and I'm going to highlight this with a very different color so it stands out. do not use 2x6. Okay, we're not going to use any 2x6s in our project. We're going to stick with 2x10s, 2x12s, 2x8s. We don't use any 2x6s. That's for a very, very small platform. There's no point. Plus, the variation of the size is too much to work with. So that's why I've got that note in here. This, we only have two different options. That makes sense because anything else becomes too strong, too big. Our span is only 9 feet. So here I have a couple that I've selected, or 9 foot 3 3/4. I've got a couple that I've selected. Look at that. The 2x6 could handle a 9 foot 4. I'm not going to go with that. So I'm only going to be using the 2x8s with strapping, which is the base value, and therefore we can get away with something that is only, let me put that in the green, that has the capability of spanning 11 feet, even though we only need 9. So that's a very simple one to look at. Same with the supported length. This zone is very short, right? You can see that this is very small. However, the column to column is fairly large. So it does value investigation. The supported length in this, the actual supported length in this is only 6'7" and 1/8 of an inch. The column to column spacing, though, is fairly large. So let's take a look at how this affects the beam selection, because I think it may not be something that you would find, or you may find surprising. So let's take a look at this. Since our supported length is 6'7", here's our 7'10". That's the base one. Sorry, I used the wrong color. That's the base one that we're going to be using here. I'm leaving the other one up for comparison. Our span, our column to column span, though, is 12 foot 11 1/8. So where do I find that? Well, my first one is until way down here, which is 4 2x10s, and then my next one is here. So even though this beam is supporting very little supported length, which is the width of the deck, it still requires pretty substantial beams to support that. We're going to deal with 4 2x10s and 3 2x12s, and that's what I've got listed here. Remember, these values here are the ones that are coming right off the building code. And so we may need 2x10s or 2x12s, just like in here we needed 2x10s and 2x12s, but we just needed one less ply. So 5 2x10s is the number of plies, obviously, and 4 is the number of plies here, so we're one less. See, this is what I mean when we're looking at consistency. When I look at the overall project, if I can get away with all 2x10s, then that's what I'm going to do. I'm going to select 4 2x10s on this one and 5 2x10s on this one. But if there's a section that needs a 2x12, it may make more sense to pick all the options that use 2x12s. Use less plies but more wood. So that's why we need to calculate every single scenario in order to come up with the final solutions that we pick. Okay, so let's take a look at Zone 5. Zone 5 is a bit unique because it passes through a couple of different zones. So I have Zone 3. This is a simple example, very much like through AA. This is through CC this time. And Zone 3 is a very basic kind of overhang with that, although we have the beam that's attached to the side of it. What I wanted to bring to your attention in this one is we have different height beams supporting different parts of the decking. Now there's actually a third beam out here, so I've only shown beam 4 and beam 2. There's beam 4 and beam 2. But this purple part of the deck, actually, or magenta color, actually is support on beam 3 as well. So if I were to colorize this to help us visualize what we have, this part of the deck is our upper deck, and we've drawn this already once or twice. And then the lower deck is the magenta colored one, and that one keeps going. And I've only shown it as a variable that ends right there, but it keeps going and is supported on a second beam. So section C, notice how I brought the line here? It's showing that I'm cutting through the deck. That's why it's shown here as a cut through the deck. If I showed this section line to continue down below beam 3, I would have to show the entire deck. Now, why don't I? Because we've already calculated Zone 4. Since we calculated Zone 4 here, in the worst case scenario, which is the furthest part of the beams, or sorry, furthest part of the column to column, I don't need to calculate it here. These are much closer together, so they're not going to be influenced by this calculation whatsoever. So I basically ignored zone 4 here because we've already done it, and we're just going to focus on zone 3 and 5. And again, it simplifies the calculation. Where do the numbers come from? Once again, when we look at zone 3, I've got it on the actual PDF file here. There is the joist span for zone 3. It goes from the building to the first beam. There's my first beam, or beam number 4. You can see it there. It's 9'8", and that's what I've calculated here as the joist span. The next one, the span is 8'5 3/4 from beam to beam, 8'5 3/4. And again, we use the center lines of the beams because we don't know how many plies we're going to be using and what the actual number is. So our actual numbers that we're using are always slightly bigger than what they will be in reality, and that builds in another level or another safeguard level into our project. So once again, I'm just going to highlight the information that's used in our calculation. So to calculate the supported length, it's the joist span on the left, on the right, divided by 2, and then that will give us our number that we're going to be working with, our supported length, and that number is what we're going to be using down here in our supported length. And the 11-inch or 11'8" 8¼ is the number that we're using for C. This is the maximum beam span between columns. There's my number, 11'8½", I think it is, sorry, 8½. That's the number I'm using here. So again, that's the actual. My joist spans are simple. 9'8", I'll calculate that. 8'5 3/4", I'll calculate that to get the OBC values and what we're going to be using there. And you can see I'm moving much quicker now through it. That number has to always be greater than this one here. And by it being greater, we know that it will meet the requirements of that number. Here are the two for our supported length. The supported length, even though we only needed 9 foot 0 7/8, we had to go to 11'10" on the table. And that's how we generated the numbers here. Once again, here the SPF for 1 and 2 for our joist span. We can go, or that particular joist, 2x8 with strapping can travel a length of as much as 11 feet at 16-inch centers, just like it did above here. And so therefore it's far more than what we need. We only need 8 feet. And once again here you'll notice I've made a note, and I will highlight it once again. We do not use 2x6s. And since the calculation for the joist is far greater or far larger than what we need, we don't need to select any others because they're all going to be bigger. So zone 5 is a real simple no-brainer. This section in here, it's a small span. The beam itself, we've really only calculated the supporting length for it. That was our only concern, was beam number 4 in here. The rest of it is all calculated. So this has gone through my entire project. Once I have done all these calculations, I will sit and go through every single number and see if there's uniformity. And that's what eventually helps me determine what I've done here, which is basically all my joists and all my beam sizes. So I try to get as much consistency as possible. So in my particular case, all my joists are 2x8s along here. All of my beams are 2x10s except for beam number 1. It's a 2x8. And that's something that it's the smallest one that's there. For me to go to 3 2x10s, I could. It would be far beyond what I need. So that's why I selected a 2x8 in terms of a beam. And I'm okay with that because the joists are 2x8. So any cutoffs, or when I do the orders, I'm ordering only two sizes, 2x8s and 2x10s, and most of the 2x10s are for the beams. And then I've got all my max spans on each one of these right on the drawing. So in case somebody is building this off the drawing and they're digging holes, and for whatever reason they can't place the column in that hole, there may be a lot of rot, there may be sand, there may be moisture, whatever the reason is, and they have to move the column, they can immediately look at this chart and say, oh, how far can that span be on that call them. Okay, we're still safe within that distance. It just helps the builder without and saves some time without them having to come back and forth and provide or identify some sort of amendment to the drawings, or they know they can go ahead. And the secret is basically this: in a lot of the projects, quite often when there's a change that's made on site, if they understand that they can make that change, they make it and then reapply or put an amendment into the permit process to make sure it is recorded on file. Well, hopefully this helped you with your calculations. Remember, this is lesson 6. It is due at the end of this week, Friday before midnight.